Here we have a sketch of the graph y equals tan theta. We've got theta in degrees along the x-axis, and we've got the output values here on the y-axis. Now the first thing we notice are these vertical dashed lines. Well, each one of these is called an asymptote. An asymptote is a line that a curve approaches as it heads towards infinity. You see, the graph at each of these points is undefined. So tan theta is undefined when theta equals 90, and then again at 270, and again at each of these points. Why is that? Well, tan theta equals sine theta over cos theta. So at any point when cos theta equals 0, tan theta is undefined because you cannot divide by 0. For example, cos of 90 is 0. So that's why it's undefined here at 90 degrees. Okay, other things about this graph. This graph has a period of 180 degrees. It's a periodic graph, which means it repeats every period, and in this case it's 180 degrees. Look at the shape, there it is, and then it repeats again, and it repeats again, and it repeats again, and it repeats every 180 degrees. That allows us to say the following: tan of theta plus 180 is equal to tan of theta. This is a really important result. Another thing is that this graph, it has rotational symmetry about the origin. It has a rotational symmetry of order 2. It means the graph is an odd function, and we can say this, that tan theta, or minus tan of theta I should say, is equal to tan of minus theta. This is also an important result. Let's have a little look at solving some equations. Now we'll set ourselves a range. Let's go from 0 to 360 degrees. And the first one we'll do, we'll say tan theta equals root 3. So we grab our calculator and we make sure we're in degrees mode, and we'll do the inverse tan of root 3. And that tells us it's 60 degrees. So one of the solutions is 60 degrees. Let's find out where that is on this graph. So there's 0, there's 90, so 60 degrees. Let's say it's about there on this sketch. So if I draw a line up to the graph, we can see as we go across here that there's more than one solution in the range 0 to 360. We've got this point here which represents root 3, but there's another solution here, and this is the one that we are interested in. Now we know that it has a period of 180 degrees tan, and we said over here that tan of theta plus 180 equals tan of theta. So to find a second solution in this range, we can do theta, which was 60 degrees, plus another 180. So that will give us 240 degrees. And to check that, we can put it back into our calculator as a function of tan. So tan of 60 equals root 3. Great. Tan of 240 equals root 3. Brilliant. That's exactly what I was after. Let's have another equation. Let's do tan theta equals minus root 3. Back to the calculator. Inverse tan, this time we're doing minus root 3. And that is minus 60. So this time theta equals minus 60 degrees. Let's have a look to see where that is on the graph. So there's 0, minus 60, that's 45. Let's say it's about there. I'm just going to draw it on top so that I can draw a line down to the graph. And then just like last time, I'm going to draw a line through like this, because the answer of minus 60 is outside the range that we want, which is 0 to 360. But we can see there's another solution here, and that's within the range, and there's another solution here, which is also within the range. And like we said last time, it has a period of 180 degrees. So to find the other solutions, I'm going to do minus 60 plus 180, which is 120 degrees. And then I'm just going to do that again. This time starting at 120 plus 180 equals 300 degrees. Let's just check that on the calculator to finish. So tan of 120 equals minus root 3, brilliant, and tan of 300 equals minus root 3, brilliant. So to summarize, for tan, to find different solutions, we add or subtract 180 degrees.